Well, that was nice. Much frozen, but now we have a few minutes left, so we should do this. All right, we got a water tank built in the shape of a circular cone with a height of 5 meters and a diameter of 6. So I'm going to draw a picture. Here's my diameter of 6. And there's a height of 5. So of course your radius would be 3. Water is being pumped into the tank at a rate of 1.6 meters cubed per minute. What is that? What kind of measurement? It's volume. So we know that volume is a function of time, and we know that the change in volume over time is equal to 1.6 meter cubed per minute. Find the rate at which the water level is rising. So we are trying to find the change in height over change in time. That means height also has to be a function of time when it's 2 meters deep. So we're trying to find this when the height equals 2 meters. So now the hardest thing in these related rate problems is creating that equation. How do you write a formula for volume of a cone based on height and based on height only? So first of all, we can start by writing out what is the volume of a cone. Do you remember the formula? It was 1/3 of what? 1/3 of a cylinder. Pi r squared times height. And right now we have 3 variables. And the question is, can we use similar triangles to write that radius as a height? Because what we have is we know, that's a pretty nice looking cylinder. We know that the big one is 3/5, but what we don't know is what it is when it's smaller. But because the triangles are similar, you know that this ratio of 3/5 has to be the same as the ratio of the radius over the height. So solving for the radius here, in terms of h would be 3h/5. So now we can rewrite our volume formula, and instead of r squared, I can write 3h/5 squared. And before we So just simplified it there. Multiplied the 1/3 times the 9/25 and got 3/25. And now we can take the derivative with respect to time of the whole thing. We've got implicit differentiation. All right. So this is implicit differentiation. The derivative of v would just be 1. And then chain rule would be dv dt. Implicit differentiation on this side, derivative of an h cubed, the 3 would come out in front, giving us 9 pi/25 h squared, and then the derivative of h would be dh dt. Now what do we know and what do we want to find out? We know the change in volume over time was 1.6, and we're finding it when h is 2. So now we can plug in 1.6 equals 9 pi over 25, 2 squared dh dt. And somebody have their calculator handy. I'm going to wait for Daniel. Should we push pause? Here, we'll pause it. Okay, so 15 minutes has elapsed and Daniel has the answer.
0.354.
0.354. Perfect. This is one of the longest classes ever. First we watched Frozen, the entire movie. And now we've had 15 minutes for calculations. This is wonderful. And our units will be meters per minute, because it was meters cubed per minute for the volume. And there we have our entire question.